So I'm here to talk about maths as it appears in STEM education, as it's included in STEM education. The subtitle in the conference programme is Maths in STEM Education, Where Does It Fit? And I don't think I'm giving too much away if I suggest that it doesn't really at the moment. To give you a background of who I am, because I'm not actually attached to a university, I work for a company called STEM. I'm the daughter of two maths teachers, so grew up always loving maths, doing maths. It was something that we did on a rainy Sunday afternoon. Ended up going and doing my first degree in archaeology, in Egyptian archaeology. Through that, weirdly got into a PhD in history and philosophy of maths, looking at Egyptian mathematics and science communication, which I did as part of a physics department, which is a bit strange. Since then, I've worked for the British Science Association on STEM Clubs project. I'm also involved with the National Science and Engineering competition, and I judge that competition and chair judging panels. And I now work for STEM. We're a small company based in Liverpool. We advise schools in Merseyside and Cheshire to do all sorts of funky STEM education stuff. We're the STEMnet contract holder, if that means nothing to you. We also get funding to do work with people like NHS Careers. So this topic of maths in STEM education, and I'm particularly going to focus on maths as they appears in STEM fairs, is something that has both an sort of intellectual interest for me and the sort of philosophy behind how it appears. It's also one that's a real practical problem for me, because I'm organising a STEM fair on the 8th of July, which is something which, whenever I mention that, slight panic. I've got about 3,000 kids to turn up and entertain with maths and STEM. So why fairs in particular? Because for me, STEM fairs are a physical embodiment of where we're up to with maths in STEM education. It's there for us to go and look at. There's floor plans, which as an archaeologist, that's something that I can get behind. And again, because STEM fairs are developing, it's an emergent thing, and you know, we need to get in now and sort out where we want maths to sit. In the reviews of my abstract, I was asked to try and define the STEM education. I realise I've got people from outside the UK. So I'm going to start with the definition of, this isn't working. There we go. Okay, so Science for All report in 2010 was a government-funded report chaired by Roland Jackson, who was then Chief Executive of the British Science Association. And this is the sort of introduction where they try and define what they mean by science. The Science for All report was about the current state of science outreach in this country and where we want it to go. And you can see what their definition is. And this is just the definition of science before we get into anything else. We've got physical, biological, engineering, mathematical, health and medical, natural and social disciplines, and also research into the arts and humanities. They use that definition because they're trying to include a whole load of different things under one umbrella and talk about it. So where does that leave us with what STEM is? There we go. STEM, science, technology, engineering and mathematics. Some of you may remember when it was SET, which didn't include the mathematics. Adding the N to that is something that's happened over probably the last 10 years.
They've added another N now, haven't they?
Sorry?
They've added another N for medicine.
Thank you for my next point. Yeah, depending on where you're from, you may also have slightly different acronyms from the same thing. We can sometimes add an N to include medicine explicitly as a separate thing. South Africans would include an I on that to include innovation. It's a whole load of stuff depending on who you are and where the funding comes from. So it's been invented as a shorthand to kind of describe a set of subjects. And I don't think anywhere has it been specifically, philosophically defined as something. The word STEM gets its meaning from how it's used among a whole range of different organisations, including university outreach departments, industry, employers, professional institutions, and it's used as a kind of umbrella term to try and bring a whole load of separate people that have an interest in STEM education together and an attempt to try and get us working in one direction. One of the reviews actually suggested that I ought to talk about what the STEM movement is, and I allowed myself a little time to dream of the day when I'm part of a movement, because that suggests sort of direction and purpose, which I don't think at the moment STEM education has. In my work as an advisor to schools, and I talk to a lot of teachers, I often have meetings where teachers say to me, we want to do STEM education. What they mean by this, and this is how it's used in schools, integrated, mostly project-based problem solving, either as individuals or as part of groups, but definitely sort of practical project-based learning. It's the topic of another paper, but I think what this shows is that that kind of learning is lacking in schools at the moment, and people would like, and teachers would like to include that sort of learning. So they sort of try and do it as we're teaching STEM, and there are even schools now that have timetabled STEM lessons, and this is what they try and do. Depending on the school, depending on who they are, what interest the teacher has. I've seen gardening, chess, psychology, architecture, finance, food technology, all of these things I've seen included as STEM lessons. I don't think there is anything that fits through that. If you can squint at it and call it some sort of science, logic-based thing, yeah, we'll have it, we'll include it, you know, that because we want to get as many people involved in this as possible. Okay, so where does maths come into all of this? I know the people in this room are going to tell me that there are lots of maths things out there, and yes, there are a lot of very good maths projects, ideas out there, you know, things like Enrich, the HSTEM programme, the IMA, there's lots of stuff out there, but teachers tell me they find it hard to find maths projects which they can include in this sort of STEM learning. Mostly because there's a perception that there isn't a real world context to what they're doing, and because of links to industry and careers, that's seen as an important part in this sort of thing. And you know, there's a perception that maths is outside of that and is other. Whether that's true or not, you can tell me. There's also a problem in that maths is a different department in schools. STEM is often taught by the science department. You know, you may say, well, okay, it's just two teachers within the same school. How many of you work with the department that's in the building next door? This isn't an easy thing to do, to try and get science and maths working together. And including maths as part of this is always seen as doing maths by stealth. We'll pretend we're not doing maths really, and we'll sneak it in there somewhere. And you know, maths by stealth, I put it in quotes because that's not my phrase, that's something that continually comes up, that doing maths as part of this project-based learning isn't really doing proper maths, is it? We're hiding it in there. Okay, so that's an introduction to STEM education, where maths fits into sort of general STEM education. On to what I really want to talk about, which is the Big Bang Fair, because this is the one that I have to organise. I've been to it's been running for 6 years now. I've been to 4 of the national ones and worked at 4 of the national ones. So there's a national fair that's held during Science Week, which in the UK is March, which is run by an offshoot of Engineering UK. There's a regional programme that's managed by a set of regional delivery partners, and that's where Moses Stone fits in, that's where I fit in. We're one of those regional delivery partners. And then what we're also being encouraged to develop is an even smaller set of fairs held throughout the year in conjunction with FE colleges, with universities, with anybody that will give us the time of day and the room to run it in. And it's supposed to be a collaboration of business, government, professional institutes, universities, FE colleges, anyone that has some sort of interest in STEM education. The idea is that under the Big Bang umbrella you can bring them all together and do something special. It's a growing programme. Here's a graph of visitor numbers for the last 6 years. So see that this year's fair attracted around 70,000 individuals from all over the country. So that's quite a lot of kids. It's an enormous thing if you ever get a chance to go and see it. Regional programmes, those sorts of numbers, so that's a total of 28,000 there over a series of fairs, averaging around 2,000 per fair. So you can see last year's North West Fair attracted 2,160. I've got to beat that number this year. Our target for this year is 3,000. It's a little scary. And then here's the list of last year's smaller fairs, which are a real mixture of events. Some of them just having 100 people, one of them attracting 5,000. So there's an enormous range of stuff happening under this sort of umbrella of the Big Bang and through regional partners. What's it for? The only thing that I can find where they state publicly what this is for is on the website, where they say everything we do is aimed at showing young people the many exciting opportunities there are for them if they have the right experience and the right qualifications. So there's 3 points, I think, come out of that. It's about the range of STEM careers, so that's range as in, you know, the difference between particle physics and biology and food technology, but also the range between being a research scientist and being an engineer for British Gas. So it's a subject matter range and an intellectual range that we're dealing with. Excitement, remember that word, we may be coming back to it. And the right qualifications, it's about giving them information about, you want to do this, this is what you need to go away and do. And the best people to tell them that are people that are actually working in it. So that's what they say. Then this is the question that comes up time and time again in internal evaluations of what they do. So this is something that I have pulled out of something they sent me as a regional delivery partner, and this is their own evaluation. I apologise for this graph. I didn't plot this graph. The three-dimensionness of it is nothing to do with me, so blame somebody else for that false perspective. Okay, so what can we see from this? BM is the benchmark, so among a general population, if you ask them, do you want to do a career in these disciplines, that's the sort of answer you'll give. You can see there is quite a large leap after the national, not so much a bigger leap after the near me events is the regional programme. Unfortunately, I think you can all see, even with the horrible false perspective on this graph, that maths is lagging behind quite substantially. And what's also a bit scary is that there isn't that enormous leap that you get with science. Maths, desirability of maths goes up a little bit, but not massively. And I think what that shows is that there's not an understanding that if you want to do one of these three careers, you're going to have to do maths, and that maths is useful as part of that. I've heard people talk over the last couple of days about ideal mathematics. That's a question I'm going to sidestep. I'm not going to deal with pure maths and talk about values of different types of mathematics. For me, they all have the same value. Sorry, did you want to...
What's the question that was asked?
The question is, how desirable is a career in STEM?
No, but what are the individual...
Sorry, science, technology, engineering, mathematics.
So you ask, how desirable is a
How
question in
desirable,
science?
yeah.
And they say yes or no.
And they say, yes, it's desirable. I think this is people that have either said it's very desirable or desirable. Everyone has a fun.
So there are 4 questions. How desirable is a career in science? How desirable is a career in technology?
Yeah.
Is that right?
Yeah.
And when you speak of increase, you're talking about the jump from the right-hand benchmark.
Yeah, so that's your benchmark
Yeah,
figure.
okay.
That's the figure from people that have been to a national or a regional. Yeah.
Sorry, since we're asking questions, you talk about a leap. Does that mean it's a pre and post, or does it just mean
Yeah.
that people?
So this is asked for people who haven't been to a fair. This is sort of general.
But no, that's not That's not leap. That just means that people who go to Big Bang National are more sciencey already.
Yeah, but they're not more mathsy. That's
Yes,
the-
right. They're not more
Yes, yes,
It's not
there
about
is.
leap.
Obviously
That's
not.
about what. I mean,
Yes,
I'm
this
just
is.
saying me. It's more likely.
Yeah, this
isn't it, how
is
people-
not a very detailed evaluation of the effectiveness of the Big Bang. If somebody would like to do that evaluation, then please do.
No, but I'm just saying what that
Because
shows is that what the Big Bang attracts is science
Science people.
people, but not
Maths
maths people. So I'm just like, it shows a slightly different point than the one you're making.
Yes, it does, but then I know the schools that go to the National Big Bang, we do a lot of work making sure that it's not the traditional schools that go to these. There is a vast range of
But
schools that
within
go
that
to
school,
this.
perhaps they choose their sciencey
yeah.
type people to go.
No, that doesn't happen. They are taking much bigger groups than that. This is also part of a bigger evaluation, talking to the pupils about how much they got out of doing the Big Bang. So yes, this is just a snapshot of the evaluation that's done. So yes,
Thank you.
do some more than that. I just wanted to sort of show you this graph as a sort of bit of a wake-up call to mathematicians, because it's not having the effect that is possible to have. Okay, going back to more detailed rationale. It's there to address a perceived shortage of STEM skills. It's there for a need to engage with industry, show that range of careers, and to overcome stereotypes. And this is where I'm very grateful I'm on a Saturday and I'm coming after people like Heather's paper and Marcus's paper. That the problem that we've got, and they talked about it at length, is that image of what a mathematician is. That child's drawing of the fat man with the mortarboard being really angry, that doesn't come from school education, that comes from general culture of mathematics. And I think what the Big Bang is not an educational event, but it's entirely a cultural one. For example, an analogy of that, yesterday I spent a few hours going around the British Museum after I come here. Even me as an archaeologist, I don't go to a museum to learn new stuff. I go to appreciate, come up with ideas and that sort of wider cultural experience of going to a museum. And if I want to learn something, I'll go to an evening class, I'll go read some books. And that's what Big Bang is all about. It's about saying, that's not what mathematicians are, here's a load of exciting mathematicians. This is what you could be, and raise that desirability. The archaeologist in me likes to look at maps and plans. So how can we get maths involved in STEM fairs a bit more? I realise I'm already slightly running out of time. The floor is arranged into zones purely as a way to organise the fair. There are thousands of people involved in delivering this. There are 8 zones here which have sort of STEM education content, which I've highlighted here in blue if you can see it. So Go Global, On the Move, Farm to Fork, Alive, Think Digital, X plus Y, Energise and Out of This World. What goes on in these 8 zones? Think Digital, Technology, Music, Global, Transport, Connected Green World, Farm to Fork, Food, surprisingly, Out of This World is Space. This right-hand column here is showing the main exhibitors in these zones. So you'll see there a mix of university-style things. So you've got Hughes Boson Research Project as part of this, STFC. You've also got industry involved in this. Then the other 4 zones, Alive, Medicine and Technology, Energise, On the Move, and then you've got the 8th zone is the X plus Y, is the maths bit. So what does this show me as an archaeologist? Oh sorry, here's some photos of that maths bit. Just don't want to go through in detail what's going on in this because I haven't done a detailed evaluation of this and to talk about that's not fair. Here's some kids doing a little scale drawing of the kid lying on the floor. This is Jaguar Maths in Motion. Some of you may have seen that. That's kind of maths of car racing, and you get to drive little cars and you have to tell them what angles and speed to take corners at and all sorts of things like that. This was actually quite a fun one to sit and watch. It's a huge spirograph made out of bits of a bike, and there's a bucket with sand on there somewhere, so you get the kids to turn it round and it draws nice spirograph patterns on the floor for you. This is one that was run by a university department. They were looking at the maths of movements of cows within a cow shed. So you could get a little tracker put on you and pretend to be a cow and look at the maths of that. This is Plymouth University. You may know that they've just done some quite exciting maths, breaking some World War II codes, and they were there talking about that. Cryptography is quite a popular topic to take to these fairs. I've got their handouts with me if you want to look at what they did. And the last picture here, slightly at a funny angle, is the Liverpool Fun Maths Roadshow that took some problems that kids could walk up to the table and do. So you can see the sort of anarchy that is one of these fairs, and 70,000 kids are left to sort of wander around in small groups. It's up to the individual stalls to attract those kids, get them interested in something, then start the conversations with them about why you're here, what you want to do, and so on. What does all this zoning and this floor plan tell us though? Well, my keen archaeologist's eye would take that floor and look at how it's used. And I think what this tells us is, if I block it out, that there's lots of great science and engineering, and then maths, that's this little bit that's sort of in the middle, that's corralled into a separate thing. That's not part of science and technology. Why does that happen? The Big Bang, me, Mersey-STEM, we can only book acts that are out there. I can't tell them what to do, and if they don't exist, I can't book them. So that zoning is a manifestation of what there is for me to book, and there are people that say, I do mathematics, and they get put in a maths. So the engineers aren't saying, yes, we're doing mathematics. I took a good look at the Royal Academy of Engineering stand while I was there this year. Nowhere on that stall does it mention maths at all, although I struggle to think of a branch of engineering where you don't need lots of maths. So careers are there as a reflection on sort of the intersection of the goals of all of the different people that contribute to the Big Bang. So if you draw a Venn diagram of them, careers is the bit in the middle. And I think we come across a problem where there are very few people who have the word mathematics in their job title outside of research mathematicians. It's not a word that is used as much as engineer or scientist are, so we've got to work extra hard as mathematicians to say, yes, look, actually I may have the word engineer in my job title, but what I do most of the time is mathematics. So how to integrate this? As an organiser, I have to persuade people to get involved in this based on 5-minute conversations that I can snatch with them on the phone. So my elevator pitch to try and get people involved and to try and integrate maths into this, summing it up as one sentence, what I want people to go away from Big Bang knowing: time spent studying maths is never wasted. Doesn't matter what you want to do, sooner or later you're going to need some maths, and even if you don't, well, it's good fun anyway, and you'll be better at gambling. That's the kind of message that I'd like people to come away from the Big Bang knowing. I think we've got a lot of work to do with other STEM subjects. I think we need to be working with Royal Academy of Engineers to get them to draw out the maths. It would be nice if the Space Zone had a maths thing about what shape is the universe, because that's a maths problem, but it's about space. Brilliant. We can get that idea quite easily that maths is involved in all sorts of these different things. And I think we seriously need to think about getting rid of that separate zone and thinking about how we can get maths into all of those separate bits. And there's a word that came up earlier, which is, where's the excitement in mathematics? We've talked about, over the last couple of days, the beauty of mathematics, the satisfaction of doing mathematics. Thanks to Jean-Paul, we also have the humour in doing mathematics. All of those things we've talked about. I don't think I've really heard the word excitement used. But if we're running a big cultural event for 70,000 kids, that's the word that we need to be thinking about. I think that's my time up. So I have prepared some points for discussion, mainly because these are questions that I've got to answer. We've got the contract to run Big Bang for the next 3 years, so if I don't fully answer these questions this year, I certainly need to have done it by next year. Do we want a separate maths zone? How do we feel about this idea that doing maths as part of project-based learning is doing it by stealth? Practical question, whose job is it to pay for this? Who should be paying for this? And not just on a huge, who should be paying for these enormous Big Bang fairs. This year's National Science and Engineering competition, there was no separate prize for maths. There was one for biology, chemistry, physics. There was one for communication, all sorts of different things. There wasn't a separate maths prize because nobody wanted to sponsor it. Whose job is it to do that? Where's the excitement? How do we get maths integral to what we're trying to do? How do we get maths into project-based learning? And one final question that I want to leave you with. What are you doing on the 8th of July? Love it to come. Thank you.